All right. Today we're going to look at lesson 5. We're going to look at the first part starting on page 21. And in this lesson, we start looking at incorporating algebra into our area models. So let me get my document camera up and going. And again, we are on page 21 here with area models with algebra. Okay. So here we got just a little review here. So we have 2 times 43. So we have 40 plus the 3. So you take the 2 times the 40 is 80 and 2 times the 3 is 6, which we do right here. And then that is 80 plus 6, which is 86. Okay, there's a distributive property that you probably learned in Algebra 1 or pre-algebra, where you take this 2 times both of these numbers inside, and this is why you do that. The area model really helps us with that. Number 2, you can look over here. We've got 2 times 4x plus 3. Now, it doesn't matter what this is. We can set it up like the 40 plus the 3. So 4x and 3, you have 2 times 4x, which is 8x, and 2 times 3, which is 6. But you can't add these together because one has an x and one doesn't. So you just put 8x plus 6. All right, think out loud with this dialogue here. So Michael, I get why we can break up 43 into 40 and 3, but why can't we break up 40x into 4 and x? Well, 43 equals 4 plus 3, so we can treat it like a distance and add the length of 3 to the length of 40. But 4x equals 4 times x, and it's 4 copies of x. As distance, that's 4 lengths of x. Michael says, so what would 2 times 4x plus 3 look like? Let's draw a model. Okay, so then they draw this model. Notice here you've got 4 x's because it was 4 times x. So this is a length of x 4 times. I don't really know what x is, so I'm just going to draw it this way. Whatever it is, that's 4 of them. Jay says, that's like how I would think of it. Think to double 43. I'd think double 40, double 3, and add them together. Michael says, so let's think of this the same way. Since we're starting with 4 x's, it makes sense that doubling them just gives you 8 x's, just the same way as doubling 3 gives us 6. So 2 times 4x plus 3 equals 8x plus 6, because you're doubling both of those things in there. Hey, look, 4x plus 3 is 4 x's plus 3. And 43 is 4 tens plus 3. I think there's a connection there. I guess multiplying with variables works like multiplying with numbers. Jay says, and 4x plus 3 and 43 are exactly equal if x is 10. If x and 10 are the same thing. So when x equals 10, what they're saying is if x is 10, this 40 is the same as this 4x. Okay. So it doesn't really matter what x is. We can treat it the same as a number. So 3 times x plus 2. So you have x plus your 2 times your 3. So you have 3 times x is 3x. 3 times 2 is 6. So you get 3x plus 6. Excuse me. Now here it's like our 2-digit number. It says the times sign X looks like an X. So in algebra, we use this dot or nothing at all. 3x is the same as 3 times x and 3 times x. So you got two different ways. We use the dot or just nothing. So here it's like having a 2-digit number. You have x plus 2, y plus 3. You're still going to multiply them. So x times y is xy, y times 2 is 2y, 3 times x is 3x, and 3 times 2 is 6. And we like to put our letters first. So you have xy, so xy plus 2y plus 3x plus 6. The structure of the model depends on the number of terms in each factor. Okay, these things right here are called factors. We can rely on the structures of the area model to organize and calculate, even if the values being multiplied are unknown, like x or b. Okay, here we have 8 times 2x plus 6. So 2x, 6, and you have an 8 down here. Okay, so this would be a 1/2. So we got this right here. Okay, so 8 times 2x is 16x, and 8 times 6 is 48. So then you have 16x plus 48. Here we've got 7, so 7, 4b, 6. So you have 7 times 4b, which is 28b. 7 times 6. This is one of those weird ones with addition or with multiplication. And the way I think of sevens is usually the hardest for most people is if you think of dot math. So if we have a 6 here, dot math puts 6 points on there. Okay, and we're putting 7 at each one of these points. So if you picture that there's 2 7s right here, which makes 14, you got 14, and you get another 14, and you get another 14. So 7 times 6 is the same as 14 times 3, and then most people just add this together. So you got 4, 8, 12, and then 1, 2, 3, 4, 42. Those are for people who may not memorize all of them. Okay, this is some quick dot math to help you out. So you got 28b plus 42. Okay, now we just have letters. So you got A, B, and C. And in class, I told you that when you put letters into things, okay, if it's just letters, things become easier because you don't have to do the actual arithmetic stuff. Okay, so A times B is AB, and A times C is AC, and then we just have to add them together. AB plus AC. Everybody should be able to do this multiplication right here. It doesn't matter if you remember the multiplication tables or not. All right, page 22 will be the last one in this section here. What multiplications are shown here and what are the answers? Okay, so you have 2x. So because there's 2 x's right there, and you got 1, 2, 3, 4, 5 y's. So you got 2x times 5y. And if we look here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 xy's. Okay, well, 2 times 5 gives you your 10, and your x times your y gives you your xy. So that's how we get it. Okay, so here we've got a little bit different. We've got 3j. Okay, there's 3j here, and there's 4k and a -2. So this is 4k minus 2. Or sometimes they'll put plus -2. I don't like to do that. Okay, we like only one sign in there. So what does this equal? So we've got 12. So there are 12 here. These 12 are all JK. So 12JK minus 6J. Because you got 3 of them. Okay, you got 3 of them and they're each -2. Here we have 5y and x plus 4. So then we have 5xy plus 20y. And notice they're in separate boxes here in this case. So I can't add them together. This one has an x and a y. This one has a y. Sometimes you'll be able to add them together. Like over here, we can add all those together because they have the exact same letters. Okay, here in the yellow, it says area models work the same way for any multiplication problem with 2 factors. The 2 factors go on the outside as there are 2 side lengths of the rectangle. Then multiply the factors to find the measure of each piece of the area. Finally, add the pieces to find the total area inside the model. So if you have 2 terms, okay, or 2 things that you're multiplying, you get this 2-dimensional shape. I think I talked about in class one time, if you were to take 3 terms, you would actually have to make a 3D model of the item. Okay, so if I want to take like 2 times 3 times 4. Okay, so one side would be 2, 3, and then 4, and you'd have to multiply all those together to get the stuff inside. Okay, and that's some higher level stuff. We're not there, but I just want to show you that even if I have more than one term, I can keep using this area model to help us out. Okay, number 11. What are the factors of this model? So looking at this model over here, I've got y plus 5, and I have x plus 2. And you can switch these around if you want, it doesn't matter. Fill in the area of each of the smaller rectangles. Okay, so we're going to multiply here. X times y is xy. X times 5 is 5x. Y times 2 or 2 times y is 2y. And 2 times 5 is 10. What is the product or the area of the model? So you got xy, 5x plus 2y plus 10. And again, the order here doesn't really matter. 14, complete this model to find 3 times a plus 2b minus c minus 5d. So we got 3 up here. We got a, 2b minus c minus 5d. So we're going to take 3 times a is 3a. We've got 3 times 2b is 6b. 3 times negative c is negative 3c. And 3 times negative 5d is negative 15d. Okay, that would be like, for this one, I would have 3 negative 5d. So I'd have negative 5d, negative 5d, negative 5d. Okay, in total, I have negative 15 d's because they're all d's. Again, we're not multiplying these together. So what is 3 times a plus 2b minus c minus 5d? It is 3a plus 6b minus 3c minus 15d. All right. Draw an area model and use it to multiply. So we got b negative 7, a plus 5. So we got a times b is a b. 5 times b is 5b. A times negative 7 is negative 7a. And 5 times negative 7 is negative 35. So you got ab plus 5b minus 7a minus 35. Okay, and this is the part hopefully we can start visualizing in our head when we do these. So we have a plus 5, b plus 2c minus 7. Okay, so we've got ab, and then a times 2c is 2ac. A times negative 7 is negative 7a. 5 times b is 5b. 5 times 2c is 10c. And 5 times negative 7 is negative 35. So then we just need to add them all together. If you look through here, none of them have like terms. So we have AB plus 2AC minus 7A plus 5B plus 10C minus 35. Again, I went this way when writing it. You could have went down if you wanted when you were writing that. Okay, always, sometimes, or never. If sometimes, say when. When does A plus B equal B plus A? When does A plus B equal B plus A? And that would be always. When does A plus B, or sorry, when does A times B equal B times A? Okay, that is also always. And we could put some numbers in here. We could say 2 times 3 is 6, and 3 times 2 is 6. Or over here, we could say, just to prove it, your only weird parts are going to be like when you have a positive and a negative, or two negatives or something like that. So like in this one, if we say negative 1 plus 3, okay, negative 1 plus 3 is 2. Does that equal 3 plus negative 1? And it does. Okay. So when does A times B plus C equal AB plus AC? Okay, we could draw an area model out for this. So we have A and then B plus C, which I think we actually did on this other page here. Okay, right here, we actually did that. And you can see that it equaled AB plus AC. So this is always. When does A minus B equal B minus A? Okay, we can look at this and get some numbers here. So let's just use these numbers up here. Negative 1 minus 3, which is negative 4. But then you have 3 minus 1, sorry, 3 minus negative 1, which is positive 4. Okay, so these don't always equal. Another common concern would be if the numbers are the same. So if we have 3 minus 3 equals 3 minus 3, 0 equals 0. So it does work there. So this is a sometimes when A equals B. When they're the same, it'll always work out. When does A minus B equal negative B plus A? Okay, well, if you notice here, B is negative. Okay, so I can write, and A is positive. I can write positive A plus a negative B. And if you notice over here, this is a negative, this is a negative, and A is a positive. A is a positive. So this is an always. Okay, you really have to pay attention to the signs. Over here, A was positive, but over here, A is negative. So that's what caused the issue. when does AB plus C, when does A times B plus C equal AB plus C? Okay. Now, this is a little bit tricky because there are cases where this will equal. Okay. There are cases, and that would be if A is 1. Okay, because I could have a little 1 here. I don't know why they would put the A there if A was 1. Or if C equaled 0. Okay, those are two really tricky cases that would probably be hard for you to go through and find. But if C is 0, this goes away, and I just have this. Okay, and I would get a number here, but I wouldn't get a number there. Circle all the expressions that are equivalent to AB plus CD. Okay, so you're multiplying AB and CD. So this is A times C, and I'm not doing that there. This is CD, which I did here, and AB. So this one works. This is BC. I'm not multiplying B and C. This is DCBA. So that one works. Okay, and we can just change those orders around just a little bit. Circle all expressions that are equivalent to 3 plus F times G plus F. Okay, so I'm not multiplying anywhere here. So I got 3 plus F, H plus G. So that one works out. I have G plus H, yep, F plus 3, yep. They just switched the two factors. G plus F, okay, I did not do G plus F in this. H plus G, which is over here, F plus 3, yep, I did that one. Okay, so we can rearrange some of these things just a little bit and have equivalent forms of the expression. Okay, that will conclude the first part of lesson 5 here. If you would like, on page 24, you can get started on some of these additional practice for your quiz. I do suggest that you do this after each lesson. You know, just do 5 of them on this lesson, and then after the second lesson, you could do the rest of them. Okay, or do half on one, half on the other. That way you're not falling behind on some of the quizzes. If you have any questions, feel free to reach out and ask, and I will see you in the next lesson.